สวัสดีครับ Today I will present the time-dependent losses in pre-state advanced modeling and prediction. My name is Surachead Lekhajarakul, PhD student in Chulalongkorn University and work for Department of Highway Thailand. Before we begin, you can download the document, the slide presentation by the QR code. Okay, why do we need to consider time-dependent loss in preset concrete? I will see the case study. The coral bevel dowel bridge is the malign cantilever post-tension bridge built in 1977 in Palau, the Iceland Ocean in Pacific Ocean, away from Manila, Philippines, about 1,700 kilometers in southeast. The calculation of the bid was made using the linear model, not taking into account the redistribution force effect from creep and shrinkage, and the result after rehabilitation is collapse because of creep and shrinkage. Okay, for overview, the total pre-state loss is including two of these. Instantaneous loss is immediate loss, and time-dependent loss is long-term loss. Anchorage set, friction loss, elastic shortening. We don't actually focus on this, but I will present it to you because to overview and approximately way to estimate of the time dependent and refine estimate the time dependent loss. You will see the formula is only one formula, and for the refine estimate time dependent loss, you will see loss many things, loss time of from time of transfer to deck placement. The first thing is shrinkage of concrete, creep of concrete, relaxation of strand, shrinkage of the deck concrete. I will explain you in the detail and how to use the formula. Okay, the topic total loss, instantaneous loss, time-dependent loss in 3.1 approximate and refine in 3.2, loss in multi-state processing, and loss for the diffraction calculation. For the total loss, I explained to you already from the friction loss, from anchorage loss and elastic shortening, and the time-dependent loss. Okay, first three term is instantaneous loss, and the last term is time-dependent loss that have a approximate way and refining way. Okay, for the anchorage set, friction loss, elastic shortening. For friction loss in the pro-tension member, you will see the formula in internal pre-stressing. Internal pre-stressing in the concrete, and external pre-stressing. You will see you can walk in the segmental box girder like this. Okay, in instantaneous loss. Okay, this time for our topic. Time-dependent loss in the approximate estimate of time-dependent loss or lump sum loss. You will see a lot of variable. Gamma H depend on H. That mean it depend on humanity, and FCI. This is for uh, member are made of normal weight of concrete. The concrete is stream or moisture and preset using the only low relaxation property. Okay, go to the refined estimate of the time-dependent loss. You will see the two terms in the parentheses. The first term is sum of the time-dependent loss at time transfer to deck placement, and the second parenthesis is sum of the time-dependent loss at deck placement to the final time. You see in the blue and purple and in red. The first thing is a shrinkage. Go to the two stages from creep C and C, and the last substitution is the last subscription is R and D. You will see its difference. The relaxation from stressing the precessing strand. Okay, let's start in Chinket part. Chinket part go to the two part. And the first part is depend on aggregate and depend on the ratio of the aggregate, water, cement press, and etc. Uh, they depend on humidity, temperature, and effective depth of the concrete. Loss of the concrete trinket. Delta PSR epsilon BID is depend on epsilon BID is concrete shrinkage strain of girder between time of transfer to deck placement, and KID is transform section coefficient that account for time-dependent interaction between concrete and bonded steel. And EP, the last one, is modulus of pre-stressing steel. Epsilon BID is depend on Ks factor of the effect of the volume to surface. KHS is depend on average annual humidity. KHS is humidity factor of shrinkage. KF is a factor for the effect of concrete strength, and FCI prime is design concrete compression at the time of processing, and KTD is time development of concrete, and T is maturity, and KID is the transform section coefficient that account for time-dependent interaction between concrete and bonded steel in section. EP is modulus of the pre-state steel, ECI modulus of elasticity of concrete at transfer. APS is area of processing steel. AG is Scott area. EPG is eccentricity of processing force with respect to the centroid of girder. IG moment of inertia of the concrete section, and psi the girder creep final time to a transfer. Okay, psi is the girder creep coefficient that depend on Ks that I mentioned before, the factor for the effect of the volume to surface. KHC is humidity factor for creep. The capital H is average annual humidity. Okay, KF and KTD I explained already. Okay, for the shrinkage time to of deck placement to the final time from the epsilon BDF concrete shrinkage strain, and KDF is transform section coefficient. EPS is the same that I mentioned before. Epsilon BDF is depend on KS, KHS, KF, and KTD that I mentioned before, but the time is different. We need to change the time because the material of depend on time. Okay, KDF change initial to change the state. Initial deck placement change to deck placement to final time. EPECS, and be careful about when you substitution AC area of the composite. IC is moment of inertia of the composite section because this time has a deck placement already, and the psi girder creep coefficient is depend on time. Same as before that I explained already. KHC humidity factor for creep, and TKD time development. Okay, end of the shrinkage. Go to starting of the creep. Go to the two part. Creep is depend on the temperature, humidity of the environment. The first state is time of transfer to deck placement. The formula is EPECI FCGP, concrete stress at the center of gravity of pre-stressed tendon due to the pre-stressing force immediately after, and the self-weight of the member at the section of maximum moment. Side B is already explained. All of this is the same when you put two substitution on change the variable on the time, and all of this is the same. Okay, the most complicated that I see the formulation is delta FPCD. It depends on so many variable. FCGP is concrete set in center of gravity is the same that I mentioned before, and you will see the capital psi. You will see the difference of the time. It has a meaning. Delta CD change in concrete state at centroid of precessing strand due to the long-term loss between transfer displacement. Okay, you will see psi again. For three of these, it depends on Ks factor of the for the effect of the volume to surface. KHC is humidity factor to keep. Kf is factor for the effect of the concrete strength, and KTD the development of the concrete maturity. KDF that I mentioned before, you can go back to see the slide in 17 and 18. End of the clip part. Go to the last one is uh, relaxation part, and has a two stages at transfer to deck placement and at deck placement to final time. Okay, the loss due to uh, steel relaxation is depend on FPT stress in pre-state strand immediately after transfer, taken not less than 0.55 fpg. KL factor accounting for type of steel taking as an FPY uses of processing steel, and delta FPR2 is equal to delta FPR1. It's very easy. Okay, end of relaxation part. And the last part is it's like a gain due to shrinkage of the concrete. After you're pulling the concrete and after the hardening is the shrinkage to uh, it's like a stressing again. It's not for the loss, but KDF and capital psi B I explained already, and delta FCD is changed in concrete state at the centroid of precessing strand due to shrinkage of the deck concrete. But delta FCDF is depend on many things: shrinkage strength, uh, area of the deck concrete, E modulus of uh, elasticity of the concrete, psi d, EPC eccentricity of pre-state force, ED, and you will see AC and IC is area composite and moment of inertia of the composite section. Two of these is depend on KS, KHS, KF, KTD that I mentioned before, and capital sign fee, capital sign is different. Only KHC is humidity for creep. Okay, loss in multi-step pre-state for the state of the construction and bridge, where more exact evolution of pre-staging loss is desired. The calculation for loss pre-stage should be made in according with the time step method supported by evolution loss incrementally of each state of the construction. For prediction, I will use the program software LASA 4D. It depends on time. The model is 3D and time is the time dimension. Our structure can change over time any number of ways in the real world. LASA supports the following construction activity: construction, deconstruction, because some part had to remove like a temporary structure, weight and stiffness will change, support and constraint will be add or remove, load, apply or remove load, tendon and material depend on time creep and shrinkage for concrete and relaxation for steel. Use a computer software state of the construction analysis model change to the structure over time. State time effect, but step, not time effect. You will see many steps, and the state need to have a time day 5, day 9, and one state has a many step. Okay, like state 2 has a 3 step, but 3 step is non depend on time. Go to the state 3 is day 30. Construction state analysis in LASA for the following the step: define structure group, define load case during the construction state and step, set up the state and step by using construction state editor. Okay, put in the time dependent material, the code for creep and shrinkage. You can drop down to change the model code CEB FIB 78 or CB FIB 90. It depends on your model. Preparing for the time effect in the Explorer, time effect on material. To modify humidity or temperature, you can type into the program. This is an example for construction the bridge to the span 1, step 1 in segment 1, span 1 and need some temporary load, and span 1 segment 2. After this, go to the span 2 segment 1 in step 3 and span 2 segment 2 in step 4. Look like this. Only one step, day 1, and many steps. I give you only an example because the running out of time. Thank you for your attention. Bye bye. Time dependent losses in pre-state advanced modeling and prediction บ๊ายบายสวัสดีครับผมครับอาจารย์